So let's suppose this is our first question for nuclear physics. And basically it is related to the application of the nuclear physics, or that how we use nuclear radiation to detect. So in this question, you can see there is an underground pipe which has a crack and water is leaking into the surrounding ground. And it also shows a technician which is actually going to locate the crack in the pipe with the help of radiation. Radioactive isotope is introduced into the water supply, and the water that leaks from the crack is radioactive. So basically, the water which is leaking from the pipe is now radioactive because we already add up radioactive material in the water. And technician tries to locate an area above the pipe where the radioactive count rate is higher than in the surrounding area. So question is state and explain the type of radiation. So we have to mention the type of radiation, and we also need to explain that must be emitted by isotope for the leak to be detected. So what type of radiation we have to use? Okay, I got answer from Omer in chat. We have to use gamma because it has highest penetration power. So basically we added up radioactive material in the water, so that material is now flowing with water. So water will also become radioactive. So last time we also discussed in the application of tracers. So first of all, we need to state. So the statement is very simple. We have to use gamma radiation. And the reason for gamma radiation, because you can see there is a metal pipe, although there is a crack in it, but there is still a thick layer of ground. So we need to use that type of radiation that can easily pass through the ground and can easily be detected on the surface of the ground. If we are using detector over here, so radiation must be able to cross through the ground and can be detected by the detector. So we use gamma radiation because of highest penetration power. It can penetrate through the ground.
There is my answer, she's correct.
Yes, because you just need to mention the type and need to explain the reason. So reason is very simple, the penetration power. You may also write that because of high penetration power of gamma. And in next part, it is mentioned the half-life of the isotope used is 6 hours. So the half-life of that radioactive material we are using is equals to 6 hours. So explain why an isotope with this half-life is suitable. So why we are using this short half-life? Because 6 hour is not a very long time period for half-life. So why we are using this type of half-life for radioactive material to detect the crack in the pipe? Basically, our purpose is to detect the crack, right? And crack can be detected in 6 hours very easily. Because first of all, we only need to find out the point where the crack actually is. Then after that, there is a digging process and repairing process. So in that, we don't need any radioactive material. So that's why we need to use a very short half-life, because when they start digging and repairing process, so radiation will emit in the surrounding. So that's why we have to use So basically we have to use a short half-life. So this time period is long enough to find out the leak. So the half-life of the material to find the crack. And the second reason is that it also contains short half-life, so it disappears quickly and it will not affect the surrounding. So basically this question is related to the application of the gamma radiation. Enough time to detect the radiation, and gamma radiation cannot cause any harm to the technician in 6 hours. Yes. So your
Right.
answer is also right, right? Okay, now we have the B part of this question. And basically we are using a cesium-133. It is an isotope of element cesium, which is actually cesium-135. A nucleus of cesium contains 78 neutrons, and nucleus of cesium-135 contains 80 neutrons. So pick one tick in each row of the table to indicate how the number of particles in the neutral atom of cesium-133 compare with the number of particles in cesium-135. Okay, so we got two ticks from Omer, and if anybody wants to add their answer, because we are talking about isotopes, so one concept is very much clear, that number of protons remains same. So definitely number of protons will be equal to cesium-135 comparing with the number of protons in cesium-133, because one check is already done. And then if we talk about number of protons, so you know that number of protons, number of electrons will be equal. And the last option is related to the number of nucleons. So nucleons basically means protons plus neutrons. So basically in 133, and you can also compare, because it is given in the question that there are 78 neutrons in 133 and 80 neutrons in 135. So there is a difference of 2 neutrons. So it means cesium particle in cesium 133 has 2 less neutron as compared to 135. So this answer is also right. Clear? Any confusion? So this
No,
is the
sir.
first question, and I think it is the easy one. And if we consider the next part, next question, so it is related to the count rate. The counter of a radiation detector placed close to the radioactive source gives a count rate of 1600 counts per second. So this is the initial count rate, and the half-life of the source is 1 week. So in 1 week, it will decay into half. And we just ignore the background radiation, calculate the count rate, first week after the first measurement. So what will be the count rate after the first measurement? So basically, what is the meaning of first measurement and then after the first
800.
800?
Yeah, 1 week. So it should be
So basically, the first measurement, this is our first measurement. And after that, we just divide into half. So your answer will be 800 counts per second. And then 3 weeks after the first measurement. So what will be the observation after 3 weeks? So how many times we have to decay the particle? How many half-life?
2 more times.
2 more times.
So 200.
Yes. Basically, we already done with the first half-life, and then we have to perform the second half-life. 400 divided by 2, 200. So basically, after 3 weeks, we will be equal to 200 counts per second. Because 800 is taken from the first half-life, this will be second half-life, and this is third half-life. Okay, in part B, we have three different materials with different points mark on it, A, B, C, D, E. And it contains alpha, beta, and gamma, which is emitting from the radioactive material. And the question is, uh, there are some hint for the sample. Sample 1 can easily pass A, B, C, D, but at point E, the radiation count rate will be low, and E point is at the last moment after passing the lead. So which particle is able to reach point E, alpha, beta, or gamma?
Sorry, sir, can you repeat?
Basically, question is, there are three types of radiation coming out from this sample, alpha, beta, and gamma. And according to the question, in this table, you can see that there are name of three different sample, and it shows you the count rate at different points. So you can see at point A, B, C, D. So till D, we have high count rate, but at point E, we have
The
less
first one is
activity.
gamma.
Yes, because gamma has the highest penetration power, and it is the only which can cross few centimeter of lead. So at point E, we only get gamma rays. So first sample will be of gamma. And the next particle only reaches B with high count rate. Then at C, it will be again low, then 0, 0. It means it is not able to move till point D and E. It stops after point C.
So it would be beta.
Yes,
Beta.
because
Beta.
beta can be
Oh
stopped
my
by
god.
aluminium. So there is a steel. So definitely steel can easily stop the beta particle. And the last one will be alpha, because it can only pass through few thickness of paper. And final part is state which type of radiation, alpha, beta, or gamma, is the most strongly ionizing. So we already discussed this one in the property of alpha,
Gamma?
beta, and gamma. Ionizing. So if you want to make
I think gamma
ionization
works
process,
on this.
gamma has highest penetration power.
Oh.
And if you remember, we discussed in the properties. So alpha has the highest ionization power because of the size of alpha and the mass of alpha. So we discuss in the properties of alpha, beta, and gamma. So more penetration power in gamma and highest ionization power in alpha due to its greatest charge, and it absorbs electron and turns into atom. So alpha particle have most strongly ionizing as compared to alpha, beta, and gamma, right? So this is another question. And if we discuss some more questions, so let's find some question related to the equation. Okay, consider this question.
So
So
we've done
this
this
will,
question so many times.
I think, yes, we done in individual
Yeah,
classes,
we
right?
have last year. Yeah.
Yes. So, okay, for all others, this is the first time. So, because it contains equation and there is only one simple concept to solve the equation. So, we will discuss in this part. Then it will be easy for you. So, this material is radioactive and it has a half-life of 20 minutes. Bismuth 214 and the nuclide notation for bismuth 214 is, so there are 83 protons and 240 nucleons. So you need to state the
So
composition of the nucleus.
aren't we supposed to mention the neutrons?
Basically, when they are
We're
asking about,
supposed to mention the neutrons, right?
yes, so when they are asking about the composition, so you need to mention protons and neutrons because electrons will be equals to number of protons definitely. So you don't need to mention the number of electron, but proton and neutrons are important to mention. So you can easily identify that there are 83 protons. Yes. So number of protons will be equals to 83. And for number of neutrons, you need to subtract number of protons from number of nucleons. So it will be equals to 131, right?
Wait, so do we have to do the working?
Basically, I just
214
do
minus
for
80.
the reference. Otherwise, it is not compulsory.
All
This
right.
calculation is not necessary, but since those who are doing for the first time, so just for the reference. So when they practice the question again, so they will remember that we just subtract the values from the total number of nucleons. And then we have a beta decay equation. So bismuth 214 decays beta to an isotope of polonium, and you need to complete the equation for the decay of material of 214. So you need to complete this equation by writing the number of protons, neutrons, whatever. So basically for beta, we already discussed about it, that beta can be written as -1, 0. So this is the nuclear equation. So we can write -1 and 0. So this is the equation for beta. So what will be the final number of protons and neutrons for polonium? If we talk about number of nucleons, so what will be number of nucleons for polonium? It will
214. Same.
214. It will remain same because you know that there will be no change in the number of nucleons. So it will remains 214. And what about the number of protons? Because we are already taking one electron in the form of beta. So it means that there will be 84 number of protons in polonium, right? To balance the equation, because you can see on left hand side we have total 83 number
Wait,
of.
so why are we adding 1?
Basically this is for equation, and when we write the equation, so equation must be balanced. So you know that when 84 minus 1 we add them, so that will be equals to
Oh, wait,
8.
yeah, no, I get it. Sorry, I get it. I get it.
Yes.
I get it. Yeah.
So to just balance the equation, so this will give you same 83. So always remember, for beta decay, we have to subtract, basically we have to add one more proton or whatever the number of electrons are there if we are using any other decay. So you just need to add that number of proton with the equation to balance it. Because conceptually we know what is happening over there, but to balance the equation, we have to write like this. So your equation will be satisfied. And again, they are asking about the count rate. So the count rate from this sample is 360 counts per second. And they are asking about the count rates after 60 minutes. So what will be the count rate after 60 minutes?
It's
This is the half-life. Half-life is of 20 minutes. And we need to,
360 divided by 2. That's
okay, so basically
130 or 75. 75.
75.
They would be 75, I
Okay.
think.
So basically always perform the simple calculation. Just do the half-life, because you know half-life is equals to 20 minutes. So in 60 minutes, you know that there will be three half-life, 20 minutes, 20 minutes, and 20 minutes, right? So there will be three different half-life. So we need to just decrease this value by half 3 times. So after first 20 minutes, it will be equals to,
130. Wait,
sorry,
is it
180.
130? Yeah, it's 180. I messed up. Sorry, I
Yes.
was doing mental math.
And after second half-life, 90.
90. Yeah, 90.
And the final half-life, it will be
45.
45. This is first half-life after 20 minutes. And then second half-life, after another 20 minutes, one more half-life, for another 20 minutes. So your final answer will be equals to 45 counts per minute. Sorry, second. So basically in this question, you find the equation that how to solve it, and that is very simple to solve. And in part C, state two of the social, economic, or environmental issues. There is a choice basically. It's up to you that either you write social, economic, or environmental issues. It's up to you. But you only need to state any two. So basically in part D, you need to mention any two type of issue, whatever it is related to social, economic, or environmental issue. So you just need to mention any two type of issue from any category. It's up to you. There is no specific condition that one from this one, second from this one. You just need to mention any two from social, economic, or environmental issue. So any issue that you want to mention, because we are
Sir,
going
is
to store,
your story or
yes, basically we are going to store radioactive material with very long half-life.
no way to dispose of it
Uh,
safely?
Okay. So basically there is a problem of storage and the wastage, all that thing, right? And definitely when they are going to perform all these process, so definitely they also required high cost for it, right?
Yes.
So it requires high cost for storage to make it protective, because we also make a boundary around it, and also use we have to use that type of material that is able to contain that radioactive material within the boundary. And we also need to manage about the wastage of it. Any other issue that you need to mention for it? Any type of issue?
Radiation can cause harm to humans.
So basically it can cause cancer because there is a very long half life. So if somebody got
Yeah,
exposed
that's correct.
to radiation, so there is a fear of cancer basically. And secondly, if we talk about the environmental issues, so we can say that if there is a land which is able on which we are able to do farming, right? So that will be completely destroyed due to radiation. So that land will not be able further to do farming on it, right? and it also occupies a special space for it, right? Because uh, when you set this all the storage, so uh, we also need to make a boundary that in this boundary no one is allowed to enter, so it will also cover your space. So people needs to move away from that area, because nobody's know about it, that when it explodes or anything is going to be happen, or anything type of radiation is going to be added up into your atmosphere. So that also causes the people to move away from that specific area. So it causes people to move away. Or let's suppose if there will be some leakage, so that radioactive material is going to be add up into your water supplies, gas supply, right?
Sir,
Yes.
could we write lead to nuclear war? Because
Uh,
they're storing it.
Basically that will not like an issue, because that is something different, right? Because many countries already store this type of material, right? So they are asking about it. So the point of war is like not very strong point. You may write that point as additional, but you will not get mark for it if you are writing in only two statements, because they are asking about two major. We are writing different points because there are multiple options, not only specific to. So there are multiple possibility, but the option of war is not like very strong enough, because we are not using that in some specific research or in some specific reaction purpose. We are only use that storage, that specific land for storage, right? Let's suppose if they mention that someone is storing that for some specific reason, so then you will write that point, because nobody's not what is actually going on with that radioactive material. It is clearly mentioned that we only use that specific area for the storage, right? So during storage, so there will be no industry or factory set over there to do experiments or to do research on it. So there will be no risk of like war type related to that radioactive material.
Okay, sir, understood.
Yeah, I was gonna say about the water part. I didn't notice
Yes,
it.
because we know that water and gas lines are already undergrounded. So if there may be some leakage through the ground, so definitely it will add up into the water or in the gas pipes which is passing underground through that specific area, right? So there are multiple storage also, that it will also cause mutations. It will also cause the people that they caught and they got sick after working on, because some we need some laborers and workers over there to store that material. So definitely there is a risk of sickness or genetic mutation, because they have very long half life. Because if it starts to leak from some specific very small tiny point, so nobody's known it. After some time, when we got reaction of that, so then we are able to identify that it caused due to that radioactive material that we stored at some specific area. Okay, next question. State in terms of the particle in each nucleus how the nuclei of two isotopes of the same element are different. So you need to mention the difference between the two nuclei of two different particles. So how the nuclei of two
They have different number of neutrons.
different number of neutrons, because they are asking about the difference, so you only need to mention they have different number of neutrons, right? If you write they have same number of proton, so that answer will not like very strong one, because they are asking about the difference. So you just need to mention they have different number of neutrons. And in next part, we have same bismuth material with 83 and 212 number of nucleons, and that is plotted on the graph also with 83 and 212. So the statement is already given on the graphical representation also. Now in the first part, you need to plot a cross labeled with Q for the nucleus formed with the bismuth emits an alpha particle. So if this bismuth emits alpha particle, so in result, what type of product you will get, what will be the number of proton and what will be the number of nucleon for that material which we got in the product of this reaction, if it emits alpha particle only. So let's suppose we have 83 number of protons, 212 number of nucleons, and we just perform a nuclear reaction. It emits alpha plus an unknown material. So what will be the number of nucleons and the number of proton for that material that we got after this alpha reaction or alpha particle, decay of alpha particle? So can you identify the number of protons and nucleons from that? So first of all, you need to know about the alpha particle. So how many protons and nucleons we are getting in alpha particle?
I don't remember. I forgot.
Okay. So basically, if you remember that point, that alpha particle, the nature of alpha particle is equals to the helium nucleus.
Helium atom.
Yes, or helium atom. So basically in helium, we have 2 protons and 4 nucleons. So after subtracting that value, so you will get 81.
Okay, yeah, 81 and then uh
Need to subtract 4,
208,
208.
208.
So you need to just mark on the graph. You don't need to write the equation because they are asking the same question but in different format. So we need to find 81. 81 is given and 208. So we need to mention that cross with Q. So this is the cross and we need to mention it with the Q symbol. And after that, in second part, they are asking the same material. We need to put a cross with alphabet R, same material, but it emits beta particle. So we already solved one question related to beta particle. So if we use the same material again, so this time it emits beta. And for beta, you know that it will be -1 and 0. So what will be the remaining product? 212 remains same because we know there will be no change in the
And
number
then
of
84.
neutrons and nucleons. And this will be 84 to balance the equation. So 84 and 212, this point is for symbol R, right? So this question is also related to the equation of alpha decay and beta decay, but they ask with some different pattern. Concept remains the same. And finally, you need to calculate the count rate again. Half-life is equals to 60 minutes. and it is placed at a fixed distance from the detector. And the initial measurement is so initial measurement is 24 counts per minute. So calculate the count rate from the sample 5 hours later. So what will be the count rate after 5 hours? Because value is given in minutes and they are asking time in hours. So basically 60 minutes is already equals to 1 hour, right? So we don't need to convert anything. So simply we can say that the half-life is equals to 1 hour, right? So after 5 hours means we have to perform how many half-lives?
5.
5 half-lives, simple. They only confuse you with different units.
Is it 75?
Yes, basically we need to just divide this into 5 times. First half-life, second half-life, sorry, 600. Third half-life, fourth half-life, 1, 2, 3, 4, and finally the fifth half-life. First half-life, second, third, fourth, and fifth. Okay. So in this way, we can easily just identify the half-life. Because the process of half-life is very simple. Just first focus on the number, then identify how many half-life you have to perform, and then just divide it by 2 with the number of half-lives, and you will get your answer. And we have another question. We have uranium because this section is a short section. So that's why your questions will also be short, equals to 6 marks, 7 marks, 5 marks like this, because this is a short section. So we have again two isotopes, uranium 238, 234. They are isotopes of element uranium and both are different. Both decay by the emission of alpha particle, by an alpha particle. So in terms of particles, state how a nucleus of uranium 238 is different from nucleus of 234. So in terms of particle, how these two
They have
elements
different
are
number of
different.
neutrons and nucleons.
Okay. So basically in terms of particles, if we count, so there are 4 more neutrons in uranium 238, right? So uranium 238, uranium 234. And again, they mention although the two nuclei are different, they are both nuclei of uranium, state a property that make these isotopes the same element.
They have the same number of protons.
They have
Same
same number
number
of
of protons,
protons.
but very
Yes,
different numbers of neutrons.
yes, because they actually split the question into different components and they are asking about the same concept in multiple questions. So if we talk about the properties, so they have number of protons. And next part is when alpha particles pass through air, they are more strongly ionizing than beta particle. Suggests two reasons why alpha is more ionizing than beta.
Because they're heavier and they move slower.
Yes, because we already discussed in the previous question that alpha is more heavy, it contains more mass and it moves slower as compared to beta. It moves slower than beta particle. And it's up to you if you write two different points that alpha has a greater mass as compared to beta and alpha moves slower as compared to beta. Further, the charge of alpha is greater than beta. You can also write alpha contains more energy as compared to beta. So it contains more energy as compared to beta also, right? And the last part is related to an experiment. Alpha particles are allowed to strike a thin gold foil in a vacuum. Almost all the alpha particles pass straight through the gold foil undeflected. Only a few small number of alpha particles are deflected from their original path. The result reveals certain features of the atoms of the gold state. What is shown about atoms by the fact that most alpha particles pass straight through the gold undeflected. So which fact explains you that alpha particles pass straight through the gold undeflected? So we also discuss in the results of
I
the
think
gold
since
foil.
the particles of since the alpha particles are pretty heavy, I
Hmm.
think they can go passing through, while the very few particles go
Hmm.
deflecting.
Yes. So very few will be deflected, and you remember that they deflected from the center, right? And rest of the part is we consider that atom is mostly empty. So that's why alpha particles are passing straight without any deflection, right? So atom is mostly empty and the nucleus concentrates in the center. So this fact help you to identify that most alpha particle pass straight through the gold undeflected. And next is some alpha particles are deflected back the way they came. So
Well,
when they,
don't they like go to the sides also? That's why they're getting
yes,
deflected.
in first part they are asking that when they just moving around, not from the center, from the other part of the center. So they move because there is empty space, and from the center and the edges of that nucleus, they just got deflected. So from center, they completely deflect. So we discussed that there is a strong positive massive charge in the nucleus because there are only number of protons in it and number of neutrons. So neutrons are neutral and protons are positive. So that's why we can say that the central nucleus or the central part is densely positively charged. So basically center of an atom, positive charge, and alpha is also positive, so it can easily be repelled by it, right? So these are some questions from the nuclear physics section.